Good evening, guys. Am I audible? It's visible, right?
Sir.
Thank you. Have you guys solved any problems related to this method of sections? Any problems? First of all, then I guess practice it or not. Reflections, method of sections, method of joins. I haven't received any single doubt, so that's why I'm just asking you.
Okay, Vishnu, that's fine.
Thank you for your response. And what about others? Have you guys solved any problems?
Sir, yes, sir. We solved, sir. Solved trusses, method of sections and method of joins.
Are you guys going to solve it, or is there any still the area that still we have to discuss?
Sir, solved only very few problems, sir. We'll go through it and we'll convey you, sir.
Yeah. Okay, it's just like the same thing is like we don't even know exactly whether whatever we discuss that will come in the exam or not, but at least the concept will be same somewhere here and there. We just have to apply our mind at some point of time. That's where the problem with analysis is. We have to. No other area, no other option. So the more you practice, the more you will face different types of problems, and then your knowledge on this will be increases. So that's what it is all about. The more you solve, the more variety of problems you will get. Okay, I think let's wind up this chapter, stress analysis, and then quickly let's start for the influence line diagrams, as it is one of the very important topic that we have to discuss. So briefly, can you guys tell me what is influence line diagram? Don't tell me an exact definition.
Sir, moving loads.
It is a deflected shape for moving loads, sir.
Okay, now let us start with a simple example. Let us say we have considered a simply supported beam. Okay, let us imagine that there is a point load somewhere here. I don't know, I think you guys will quickly say the answer this to me as per I know. Is this the shear force diagram?
Yes, sir.
Somewhere here, right? Suppose if it is exactly at L by 2 and L by 2, we know that this is P by 2, this is P by 2. No need to solve it, right?
Yes,
You
sir.
guys might have seen this in strength of materials too, isn't it?
Yes, sir. Yes, sir.
Right? Bhumte will get back to you that point. As of now, let's concentrate this. So, how you are defining shear force diagram here? Like, what is it represents? This is what the diagram. What does this represent in general?
Length of the beam, sir.
That means it just show us the variation of shear force. It will just show us the variation of shear force along the length of a beam, isn't it? That means here what is constant? Load position is constant. Here load is not moving at all. Load is sitting at the midpoint only. So if the load is sitting at the midpoint, because of that, how your shear force is varying from point to point along the beam. That means if I talk about point A, what is the shear force acting at that point? From this diagram, we can say, if we speak with respect to sine, P by 2. If we are talking about C, as the load is sitting at point B, what is the shear force at point C? P by 2. Can you tell me, if there is load acting at point B, what is the shear force at point B? What is this answer?
It's P, sir.
Shear force at point B. I need response from everybody, guys. I think 5 members are there. Let me ask one by one. Andal, what is the shear force?
Sir, P by
Yes,
2,
please.
sir.
P by 2. Okay, from for Andal, P by 2. Anita? Anita, no shear force. Okay, done. Monisha? I think few new people are coming to the classes, it seems. I don't know whether she has attended or not. Sorry if I forgot your name. Sorry. Ramya?
Sir, it is P, sir.
For somebody it is P by 2, for somebody it is P, and for somebody it is 0. And for Vishnu, I think he already 0. But I can say that we can't define the shear force at B. Why? Because you guys might have seen, I don't know whether this has discussed in strength of materials or not. When a function will exist, when a limit for the function will exist, let's say x tends to y or x is equal to y, what is the function of the value? How we are going to define it? If let us say if there is a function, and if you want to define whether it will exist at a point or not, how you are going to define it? Or how you are going to say that whether the function exists at that point or whether the function does not exist at the point? How can we define it? I don't know whether you guys left limit, right limit, have you guys said of anything? If left limit is equal to the right limit, then only we are going to say that the limit at that function will exist. So here, let's say just left to the point B, very close point. If I'm say, and I want to take you a section that is, let us say 10 to the power of minus 10. Take a section just left to the point B. What is the shear force that you're going to see there?
It's P by 2.
Minus P by 2 with respect to.
Right, okay.
If I'm taking a section very, very right to the point P, what is the value?
Plus.
What is the left limit? Minus P by 2. What is the right side limit? P by 2.
Right. Plus
If
P by
left
2.
limit and right limit are not matching, then do you define a point there, or do you want to
There
define a
is
point?
no function.
No. So that's why here we will say that we cannot define the shear force at point B. But what happens? Still the beam is existing, isn't it? Mathematically, we are gonna saying that okay, as the function is not satisfying, okay, then in words I am saying that okay, shear force does not, or I cannot define at that point. But still the beam is functioning even that point. So wherever those cases will occur, or even you can see there is abrupt change in the diagram. It is not continuous. From point A it is started until point B it is same continuous, but at point B what happened? The function has discontinued. Whenever there is a discontinuous function, we cannot define the value at that point. In that case, we will say that shear force at B immediate to the left. When I'm talking about immediate to the left, it doesn't mean that I'm taking it 1 meter, 2 meter. Suppose let us, if this is L by 2, I'm talking about L by 2 minus 10 to the power of minus 10. That means very, very, very close to the point P, just to the left of it. Similarly, immediate to the right. So whenever, if somebody asks you what is the shear force, wherever it changes disruptly, we cannot define it exactly, but we can define it like what is that value just immediate to the left, what is that value just immediate to the right. That's how we are going to define the shear force at point B. Okay. Now, let us consider the same beam and imagine that your load is moving. Even you can imagine there is, if train is moving or vehicles are moving over the beach, obviously what is happening? The loads are moving over the beam, isn't it? It's not like everybody, we are gonna talk about the stationary loads. Where can you observe the stationary loads? Can you tell me? These
Stationary.
type of
Where, sir?
stationary loads, that means the load position is constant. The loads will not move at all. Where we will observe these kind of loads?
All.
Self weight, sir.
Yeah, self weight. If you talk about the self weight, it will always be the same position, right? It won't move here and there. Even if you want to talk about in design perspective, if you talk about the live load, that is our load, whatever the extra load, even that we will take it as a constant position. But if you're talking about the bridges, if you're talking about some crossovers, whatever it may be, then what happens as the vehicles will move, obviously the loads will change the position from point to point, isn't it? So if the loads are changing position of the point, then obviously whatever the reactions or internal forces like shear forces, bending moment, axial force, anything, they won't be the constant. They will also changes. If I talk about any point, let us say if I talk about a point B, it is in between, let us say it is at the exactly at the center, then how shear force changes, or we can say that variation of shear force at point B as the load moving over the beam. That means here which one is loading, which one is constant. In this case, load is moving, and because of that moving, how the shear force is changing at point B, that is what your ILD, influence line diagram. As the load is moving over the beam, how the shear force changes at a point. So whenever I am talking about ILD, I am talking about a point, always remember. Right? Here, which one is constant? A point, selected point is constant, load is moving. What about in shear force diagram or axial force diagram or bending moment diagram? In this case, which one is constant? We will talk about the load is constant. Is it clear? In the first case, if load is constant along the length of the beam, see if the load is constant at different points on the beam, how the shear force changes. That's what the shear force diagram. But if you talk about ILD, we are always talking about a specific point. At this particular point, how the shear force changes by if the load is moving over the beam. That means if the load is here, what is the shear force at this point? If the load is here, what is the shear force at this point? If the load is here, what is the shear force at this point? If the load is here, what is the shear force at this point? The next thing we can ask is why we have to draw the influence line diagram, isn't it? Why? Why can't we go for SFD or BMD or everything? If it is a particular point, if the load is a particular point, then directly we know how it changes. If the load is moving, obviously we should see with the moving load how the reactions are changing on the beam, and then depending upon their changes, if we want to design them, we have to design it for the maximum value. That's why to get the maximum value at a particular point as the load is moving, then with that maximum force or with that maximum load, we have to design the corresponding structure. I think, is it clear the definition, the difference between ILDs and the conventional axial force diagram, BMDs and SFDs?
Yes, sir.
Clear? Now let us start with a quick example. Let us first solve it out. for a simple beam, let us say the point load P, it is moving from left to right. Okay. Imagine if the point load is moving from left to right, what I am interested in is that how my vertical reaction at B is changing. How my vertical reaction at A is changing. Or else what I am interested in, if the load is moving over the beam, what I am interested in is what is the maximum reaction that develop at support B and that develop at support A. If I want to find out the maximum, what we should do? We have to see, first of all, how the variation is. From the variation diagram, we'll see the maximum, and then that's what we will define it as. For that load, we have to design. So for that, what I will do, what I'm assuming that at particular instant of time, I am assuming that my load is somewhere here. My load at some point of time, my load is at a distance x from point A. Imagine length of the beam is L. Can you tell me what is the reaction at B? What is the reaction at C, at A? What is the, if at some point of time, if my load is at a distance of x from point A, what will be the reactions that are generated at the supports? Can you tell me what is the RB here or VB here? These you guys might have. Yeah, please.
L minus P into L minus X by L.
So if you are talking about a point load, total load P into what is the opposite distance to the
RB
point?
X by L. Sir.
X is the opposite distance, so P X by L. Similarly, if you are talking about A, what is the reaction P?
P
What is the opposite
into
distance?
L minus X by L.
L minus X. Always remember opposite distance. L minus X by L. Don't you guys solve this in strength of materials?
Yes, sir.
You guys solved it, right? Otherwise, again, I have to discuss all these things. That's why.
Sir, we solved, sir.
That is why I'm drawing about ILD of BB. In SM, what the guys have discussed, can you tell me? This without this, I don't think you guys should not able to complete the strength of materials. I don't think so. So my reaction at B is nothing but a Px by L. Okay. Now, if my load is at point A, imagine if my load is at point A, what is the reaction at B?
E by L.
If my load is at A, my load is at here, somewhere here. What is the X value then?
0. 0,
X
sir.
value is 0. Now see, if I put X equal to 0, how much I will get it?
0.
0. So if my load is at A, what is the reaction VB? Is equal to 0. Similarly, if the load is at B, if the load is reached somewhere here, what is the distance X value that we have to consider? From here to here, what is the X value?
L.
Isn't it? If the load is reached here, according to our convention, what will be our X value? We are
L.
taking X value from point here to the load. Now load is here. What is our X value? From here to here, L. So what is the value? P into L by L. That will be is equal to P. At point A, it is 0. And at point B, it is P. What about in between A and B? Again, wherever we want, we have to substitute the X value and then we have to find it out, isn't it? Instead, what are the variable quantities here? In the equation Px by L, what are the variable quantities?
X.
X, right? What is the power of X?
1.
1. That means if there is a function in terms of x, if there is a function in terms of x square, if there is a function in terms of x cube, if there is a function in terms of x, how it will vary?
Linear.
It will vary linearly. If it is in the form of x square, it will vary parabolically. So from a to b, as the function is there in terms of x, it will vary linearly. Linearly means what? I just simply join the line.
Line. Yes.
Isn't it? So this is what my ILD for VB. That means if my load is here, what is the reaction at VB? What is the reaction at VB? 0. If my load is here, what is my reaction at B?
P.
P. If my load is at somewhere around here, let us say if my load is somewhere around here, can you tell me what is my reaction at B? Is this the reaction at B?
P. P. Yes.
It's not directly P, right? It will
Yeah,
be
yes,
somewhere around.
Yeah.
Let us say if the total distance is 5 meters and I want to find out my reaction at B if my x is equal to 2. What I can do, I can simply substitute in this equation. My x value is 2. P into 2 by 5. That will be equal to how much? 0.4 P. Is it okay? Any doubt in this diagram? ILD for VB?
Sir, at point, sir, at load at which portion, please, could you explain once again, sir? Point 4P, how did you find, sir?
Now, where is my load? My load is at which distance? At a distance of x equal to 2.
Yes, sir.
I substituted in the equation P times, what is the position of the load? 2 divided by what is the total length? 5. 2 by 5 is how much?
Okay, okay, sir.
0.4 only, right?
Yes, sir, yes, sir. Fine, sir.
Imagine can somebody please tell me what is this value? Let us say if I'm talking about this is the ILD of VA, can somebody please explain what is this point? I just want to see or I just want to hear it from you. That's it. What does this point indicates?
Which point, sir?
This point, let us say I'm talking about this is the ILD for VA. What does this points? Can you explain what is this points represents? What is this value here? 0, right?
0.
Then can you explain me what is this 0?
Sir, at load at a point A. So that will be B will be 0.
Load at point A.
When load is acting at point B.
Where is the load? And at point you are talking
Point
the
A.
reaction. Here, the load is at which point? The load is at point B.
Oh.
If the load is at point B, what is the reaction of this? Whatever the point that you are considering here, everything is nothing but a reaction of VA. Wherever you are taking the point, that is what your representation of the point load. So if I'm talking about this point, that means load is acting at that point. Load is acting at point P. Load is acting at point B. Then what is the reaction of VA? What is the ordinate here? 0. Now, if the load is acting at point A, what is the reaction at A? If the load is acting at point A, what is the reaction at A?
Minus P, sir.
Minus P. Any other answers?
Plus P, sir.
Those, how come it's minus P?
P or plus. Sorry, sir. Upward.
There's
Upward
one
will be
element
plus
is
P.
also right.
Plus P, yes, sir.
It's clear, right? If it's clear, imagine there is a load P that is moving from left to right, and if there is a point C, I have drawn ILD for let us say, ideally for bending moment at C. Imagine, as of now, I'm just drawing the diagram. You just have to understand the concept. How I have drawn that, I will inform you later on. See, this is what some beam, the load is moving from left to right, and this diagram represents ILD for bending moment at point C. Now my question is, what is the bending moment at C if the load is acting at point A? Again, I'm asking,
Sir,
can I ask you
no,
one question?
Zero.
no zero value.
What
Sir.
is the bending moment at point C if the load is acting at point A? What is the answer?
No
Zero.
bending moment. No bending moment, sir.
No bending moment.
This load is directly transferring to support.
What about other guys? Somebody said 0. What about others?
Network issue, sir. Please once again say the question, sir.
What is the bending moment at C if the point load is at point A?
It will be constant, sir. No bending moment.
That's what, see, I just ask you the concept of ILD only. If you can understand influence diagram, I have given you this diagram. What is this diagram? Can you somebody please explain me? ILD, that means as the load is moving over the beam, this diagram represents variation of the bending moment at C as the load is moving over the beam. That means if I'm talking about this point, that means my load is acting at this point, then what is my bending moment at C? From the diagram, as you can see, what is the ordinate value from A to C? Is there any diagram from A to C or it is 0?
A to C is 0.
0,
A
right?
to Z, not diagram.
That means in this portion, wherever your load is, whatever the ordinate value, 0. That means wherever your point load here in this part, there is no bending moment at point C. If the point load is here, P, what is the corresponding ordinate? 3P. So if the load is at point B, what is the corresponding ordinate? 3P. That means what is the bending moment at C? Nothing but a 3P. If the load is here, what is the ordinate? 0. That means as the load is at point C, the bending moment at point C is 0. Here I have not asked you to draw the diagram or do any calculations. I just want you guys to understand what is ILD. ILD means as the load is moving over the beam, how the values are changing at a particular point. What is ILD diagram I am talking about here? I am talking about ILD of which one?
Bending moment.
Bending moment at point C. That means all these values, that means whatever the value that you consider in this diagram, everything is nothing but bending moment at point C, at a particular point only. But wherever you are taking the ordinate, that ordinate represents the position of the unit load. If I am talking about the ordinate here, that means my unit or my load is somewhere here. If I am talking about the ordinate of this, that means my load is here. If I am talking about this ordinate, my load is here. But each and every point represents the bending moment at point C only. Is it okay? Diagram. As you
Yes,
can
sir.
see in this diagram from A to C, there is no ordinate. That means bending moment at C is 0. That means If your load is occupied in this position A to C, there won't be any bending moment at point C. Bending moment will exist at point C only when if your load is in between.
C
My
to B.
question is it clear? Bending moment at point C will exist if load is in between. Simply see the diagram where the ordinates are existing. The ordinates are existing between B to C. That means
B to
the load is existing between B to C. Then only your bending moment at C will exist. That means between B to C. That means if your load is in between A to C, then what is the bending moment at point C? 0.
0.
Any doubt about ILD
Yes, sir.
diagram?
Sir, I have doubts, sir.
Yeah, please.
Sir, in the shear force diagram, ILD
Yeah.
of shear force diagram, we
Yeah.
have just drawn the exact shape of the simply supported beam as it is in the
Wait. Just a second. You are talking about this,
Yes,
or
sir.
you are talking about this? You are talking about this diagram, right?
Yes, sir.
Yeah, please go on.
So this diagram of bending moment, it look like the deflected shape of the particular point, sir.
Wait a second. Here we are not talking about anything about deflected shape.
Not here, sir. That bending moment at a C point, it look like a deflected shape of the member CB.
No, it's not. It may look like, but what we are talking about ILD for bending moment of C. It doesn't matter. That may looks like or that may not look like.
Sir, just you have drawn simply the particular shape.
See how I have drawn the shape.
If we were asked, no, we couldn't understand how to draw the first point.
That I will
That's
tell
a
you
draw.
later on. That I will tell you
Okay,
clearly.
sir.
But
Then
as
okay,
of
sir.
now, as of now, I'm telling you guys how to understand ILD. That's it.
Okay, sir. Okay, sir.
How we have to draw that we can clearly. I will explain you in clearly. But as of now, my point of giving this example is to how to interpret the influence line diagram. That's it. How we have to draw that I will just tell you in a couple of minutes. Imagine I am taking a overhanging beam like this, and I am taking that my load is moving from left to right. Let us say point A, point B, point C. How I am going to draw it, I will tell you. But as of now, again, as Ramya asked, just understand what is ILD. That's it, nothing else. Let us say here I have drawn ILD for vertical reaction at B. And this is what the diagram it looks like. Let us assume this is 1 meter and this is 2 meters. And let us say this is 1 and this ordinate is 3. Let us say the slope is 1/3. Sorry. Let us say that the slope is 1. Now, so whatever the ordinate that you consider, so that ordinate gives you the, which diagram we are talking about? We are talking about ILD of VB. Whatever the ordinate that you consider in this diagram, every ordinate will give you the reaction at B. Then the position of the ordinate that you are taking, that will give you the position of the point load. Now I am telling, if my load is at point C, if my load is at point C, then that means we have to talk about this point. If my load is at this point, what is the reaction at B? That you have to take the corresponding ordinate. What is the corresponding ordinate? 3. So the reaction at B is equal to 3. Again, if my load is at point B, if my load is at point B, that means I have to look at the point B ordinate. If my load is at point B, what is the corresponding ordinate? Corresponding ordinate is 1. If my load is at point B, what is the reaction at B? 1. If my load is at point A, what is the corresponding ordinate? 0. VB is equal to 0. So wherever you want to find the reaction at B, that position we have to see. Depending upon the position of load, we have to take the corresponding ordinate. If my load is at point C, what I will I just simply take? What is the ordinate at point C? That is what my reaction at B. If my load is at point B, corresponding ordinate I will take. That is what my reaction at B. So that is what ILD for B. Can somebody please tell me if my load is somewhere here at a distance of 0.5? Can you tell me what is the reaction at B?
0.5, sir.
What we have to take the corresponding ordinate. Where is the corresponding ordinate? If the load is at this point somewhere here, this ordinate we have to find out. For this ordinate to find out, this distance is given how much? 0.5. The slope is also given 1. Distance is 0.5, slope is 1. Then what about this ordinate? 0.5. So if the load is at distance of point from A, support A, then the reaction at B is nothing but 0.5. Is it clear, Ramya?
Yes, sir. Clear, sir.
Okay, then let's start the examples instead of wasting time. Let us see.
You can explain with UDL load one.
Let us say Miller-Bistra principle. Instead of going for the equation, okay, let me talk about determinate structures. The same thing. So let us say in the first case, I want to talk about the ILD for VB. We'll discuss all those cases, Anita. We'll discuss. Don't worry. Let's just start from the basic. Okay. If you want to find the ILD for VB, according to this principle, what you have to do? First of all, you have to release that force. We have to release that force and apply unit displacement. So this is what the heart of the ILD. If you do not apply this principle correctly, then you won't get the ILD diagram correctly. So that's why I will tell you, this is very, very, very important. What it says that whatever the ILD that you want to draw, release that force only. What is mean by release that force only? If you release that force, then only displacement will happen, right? If I talk about this beam, what is the vertical reaction at B? Can you tell me? If I'm talking about this in support, what is the vertical displacement at B? 0.
Yes, sir.
Why? Because there is a resisting force. So here, wherever or whatever the reaction you want to draw, what you have to do first, you have to release that force. After releasing that force, apply the unit displacement. If you apply the unit displacement, then whatever the deflected shape that you will get, that is what nothing but your influence line diagram. Is it clear? What is the first point? You have to release the force of along the direction which you here. If you want to find the vertical direction at B, you have to release that force and then apply the unit displacement. And then whatever the deflected shape that you will get, that is what your ILD. Now, here we want to find out the ILD for vertical reaction at B. So, if you want to find the vertical reaction at B, if I don't want to release that support, what will happen? Will it move along the direction of the force? If I don't remove the support, will there be any vertical displacement that happen at point B? Is my question clear? Let us talk about A. What is the horizontal displacement at A?
0, sir.
Displacement at A?
0.
0, right? If I release the vertical force, then only vertical deflection is going to happen. So here, as I want to draw vertical reaction at B, first of all, I should release that force. So if I release that force and apply, let us say I have applied unit displacement. How this will deflect? Imagine, take a pen with your hand and at left support, hold it with your hand and then with your right hand, move it to some displacement and tell me how it is moving. Take a pen and imagine your left hand support is A, hold it with your fingers and at support B, try to lift it up. How the deflected shape is gonna look like?
Like a triangle, sir.
Triangle. Right
Is it
angle.
like this?
Yes, sir.
Now the point here is, the point is what I told you, we have to release the force along which we want to draw the ILD. As you want to draw the ILD of VB, only we have to release the vertical force here. Now, as you can see here, as it is a hinge support, even you can see there is no horizontal displacement and there is no vertical displacement because it restrains it. So this is what your deflected shape. This is what your nothing but your ILD for vertical reaction at B. Now, if I imagine total length is L, what about this slope? What about this slope? Total ordinate is 1, total length is L. What about the slope here? 1 by L.
1 by L.
Isn't it?
Yes, sir.
Now imagine if my load P is acting here, if my load P is moving from A to B. So if I want to find the vertical reaction at B, what I should do? I should take the ordinate of that point. What is the ordinate of that point? 1. So multiply with the force. What is the total force? P.
L.
What is the ordinate? 1. So
Yes, sir.
if my load is at point B, what is the reaction at point B? P. Similarly, if my load is at point A, what is the ordinate at A?
P.
0.
0. So P
Sir,
into 0
ordinate at
will be equal to.
yes, sir.
So this is when your load is at B. This is when your load is at
Load
A.
is at- Yes, sir.
In between, wherever you want, let us say if the load is at X from B, can you tell me what is the reaction at B?
P into X by L, sir.
Is it right? P into X by L.
Loaded tank.
If the load is at X from B, what is the reaction at B?
Sir,
I have given you the slope. X by L
yes, sir. P into X by L.
into X by L, right?
Yes, sir.
Everybody, is it clear?
Clear, sir.
As Andal is saying yes, what about others?
Yes, sir. Clear, sir.
Clear, sir.
How come it's clear? It's wrong. What is the influence line diagram? Yes, Vishnu. This is what your influence diagram. This is 1. And what is the slope? 1 by L. This is A and this is B. What I told you, what is the position of the load? Position of the load is X from point B. So, position of the load is somewhere here. What is this distance? X. Then what about this ordinate? Where is the slope? Slope is here. So, from the slope, what is this distance? If total is L, L minus X. So, what is this ordinate?
L
L
minus
minus X by L. Load is here. Load we are considering it as P. Then, what is the reaction at B? P into L minus X by L. We have to be clear. The point is, from which direction we are taking the slope and from which direction we are taking the distance. This is where the matters, and this is where you guys might commit the mistake in the exam. Yeah, the concept is same, but you guys misunderstood the distance and slope. Yeah.
Yes, sir.
Similarly, what is the ILD for reaction at A? Sorry, 2 is pranking. What is the ILD for vertical reaction at A? How can we draw it?
We have to remove the reaction.
Unit displacement at A.
Then
What is the first thing
make a
we
displacement.
have to do?
Remove the reaction, sir. Support reaction.
What is the first thing? We have to release that force. Initially at A, how many resisting forces are there?
2.
What are they? Horizontal and
Vertical.
vertical, isn't it? Now, for which one we are drawing the ILD?
Vertical.
Vertical reaction. So, which force we have to release?
Vertical.
Vertical.
So, horizontal resisting force still exists, but you have to release the vertical force only. For that, can I rephrase the support like this? If I rephrase this support, what is the difference between initial one and this one? If I'm talking about initial case, it resists both horizontal and vertical. What about this modified case?
This is only horizontal.
This one it doesn't release. Is it clear why I have drawn this support? This is what very important if you want to draw for complex systems. Initially at A, there are 2 resisting forces. What are they? Horizontal and vertical. As you are drawing ILD for V, you have to release that force only. If I want to release that force only, so I have modified this support like this. If I modified this support as like this, then you can see, right? Only from this diagram, I can see I have placed the rollers along vertical direction. That means this can move freely along the vertical direction, but it can't move any horizontal direction. Why? Because it still exists. Now, apply unit displacement. Then how it will displace? Will it displace like this? Is it right? Again, what is the ordinate here? 1. What is the total length? L. What is the slope here? 1 by L. Is it clear, this diagram?
Sir, how we are choosing the slope? sir?
How we are?
Choosing the slope one by.
Yeah, you can ask me clearly how we are. What is the question?
How are we choosing the slope, the location of slope?
Slope. This is where. What is the
It is
displacement here?
understood. It is
Yeah.
understood that okay.
It is understood that
Understood that the opposite location of the point taken. Am I right, sir?
it's not about
Now the
opposite.
point we have taken at the A. So the
No. It's not. We cannot generalize this like that. Here in this case, it's just the opposite case, but we will
it is
define the slope
specifically
from
you are
0 point,
mentioning.
isn't it?
Okay.
We will define it from 0 point, isn't it? In this case, where the 0 point is occurring
B.
from B, right? So that's why I'm defining the slope here. Even you can define the slope here also. What is the slope here? Can you tell me? Still, it is 1 by L.
Same
But
1 by L.
what is the convenient way to represent it here?
It is at the
From
point
0
B.
side. Yeah. It just, I think, a common sense that to represent it 1 by L.
Sir, is it need the point out the slope at any particular point, sir? Is it helping for us to draw the to find out the reaction?
Like, see, if the load is somewhere here, let us say if the load is P, it is acting at a distance of X from A. Then can you tell me what is the reaction at A? From this, looking at this diagram, if you do not represent this slope, you know only this ordinate is 1, this point is 0. What about in between? How you gonna find out?
Like a similar triangle method, sir.
That also indirectly you're using the slope, isn't it?
Yes, sir.
Even if that's it. So if the slope is here, if the distance is x, what about this distance from here to here? L minus x. Then what is this ordinate? Simply L minus x by L. Every time you cannot take similar triangles, even similar triangles, it is also based on the same slope only. So instead, just represent the slope, and then wherever the ordinate required, that you can simply find out by multiplying with the distance.
Okay, sir.
Clear?
Yes, sir.
Now the same thing, what I want you guys to do is, tell me how or what is the ILD for vertical reaction at A. Just think about it. Same thing, ILD for A only. We know one thing, as I want to find the ILD for VA, I will release that force only. As I release that force, I am taking this type of support. And then I will apply a unit displacement, and then I will say the reflected shape. So if I move it to the displacement 1, how the deflected shape is gonna be? Will it be like this?
No, sir.
No?
No, sir.
Yes or
No.
Why?
No. Because horizontal and vertical will be it will be resist restriction, sir. Because supported be fixed support.
Oh, what is the difference between this case and this case? What is the type of support here? Roller support. It
It
will
will be
allow.
fixed support.
It will allow the rotation. It will allow the horizontal displacement. What about the support here? Will it allow anything?
It
Will
will
it
not
allow any
allow.
rotation?
Not allow,
Won't
sir.
allow.
Will it allow vertical deflection or horizontal deflection? No.
No,
No,
no.
sir.
As you can see here, slope is existing at point B. What is the slope at point B?
Or
1 by L.
moment, sir.
Slope, if I am talking about fixed support, rotations. So the rotation exists at point B, that is 1 by L. Even if I draw a case like this, that means I am representing there is a slope here. But what is the support at B? Fixed support. As it is a fixed support, we have to draw such that there won't be any rotation, there won't be any vertical deflection, and there won't be any horizontal deflection. So the deflected shape might like this. So as I know, so that slope at point B is 0. That means draw a horizontal line and then connect these two. So this is what ILD for VA. Now you can tell me one thing. Now see here, if the load is at A, if the load is at A, what is the reaction at A? Let us say there is a load P. That is
sir.
right. Yes, please. Yes.
Coordinate is 1, sir.
Yeah, ordinate is 1. So what is the reaction at A? If the load is at A, what is the reaction at A? Vishnu, which one you told? What is the question? This is the ILD for VA. If the load is at A, what is the reaction at A? What is the ordinate at A?
P, sir.
P, sir.
P, right?
1 into
Yes,
P.
sir.
1 into PP. If the load is at B, what is the reaction at A?
0.
0.
Because what is the ordinate? 0.
0 ordinate.
If the load is somewhere here, let us say X from B, what is the reaction at A? What is the reaction at A? Can you guys tell me?
Sir, is it triangle or some other shape, sir?
That's what I'm asking you. So what is the difference? Here it is a linear case, isn't it? As it is a linear, then I know that the slope is 1 by L. But here, it is not a linear one. It is a non-linear curve. As it is a non-linear curve, you cannot find out the ordinate. Why? Because what is this type of structure? This first one, indeterminate or determinate?
Indeterminate.
First case, this case, I'm talking about this. Determinate or
First
indeterminate?
case is determinate, sir.
Determinate, isn't it? For drawing ILD, what you are doing? You are releasing one force, isn't it?
Yes, sir.
Previously, how many reactions will exist?
3.
In the original case, how many reactions will exist?
In the first case, 3 reactions.
3. After releasing one force, then how many net reactions are possible?
2.
2. That means is it stable? After
Stable,
releasing
sir.
No,
one force,
unstable.
after releasing one force, it is unstable. Or with
Unstable, unstable.
mechanism means failure. In this case, I'm talking about failure is possible. That means if you are talking about the determinate structures, if you draw the ILD by using this concept, you will get the shape of the ILD as well as you will get the ordinate values. Why? Because as the mechanism is follows. In this case, determinate or indeterminate? Second case, I can say this is indeterminate,
Indeterminate.
isn't it?
Determinate, sir.
How many total reactions are there? Total?
Yes, sir.
2 plus 3.
5. 3 plus
5.
2, 5.
How many we are releasing? 1 for drawing ILD. That means still how many reactions will exist? 4.
4.
So, if it is an indeterminate structure, if you are using this concept, that means release the force and apply unit displacement, you might visualize the shape of the, or you might visualize the deflected shape of the structure, but you cannot still get the ordinates of the values. So this is where the logic is. If you are talking about Muller-Bristol principle, or if I'm talking about deflected shape concept, if you are talking about determinate structures, then you will identify the deflected shape and then you will get the ordinates also. But if you are talking about indeterminate case, you can visualize the deflected shape, but ordinates no. So in the you can get some questions like this in the exam. If they giving you some indeterminate structure and if they ask you to draw the ILD, you can visualize what can be the shape of the ILD, but you cannot find out the ordinates of the ILD at each and every point. So if they give you the indeterminate structure, still you might get the shape, but you don't get the ordinates. But if it is a determinate structures, you will get the shape as well as you will get the ordinates. As well as of now, is it clear how we have to draw, apply unit displacement, release the force, and then draw the deflected shape? Can we solve some more problems?
Yes,
Just
sir.
for the reactions. Later on, we have to go for again shear force diagrams, bending moment diagrams. Let me give you a simple cases. Determinate or indeterminate?
Indeterminate.
Indeterminate, sir.
Indeterminate or determinate? Sorry, I didn't hear you guys clearly.
Indeterminate.
Indeterminate, right? So let us assume there is a hinge here at a distance of 5 meters. Determinate or indeterminate?
Determinate.
Determinate, right?
Determinate, sir. Yes, sir.
Now, I want to draw influence lines diagram for reaction at A. I want to draw influence line diagram for reaction at B. I want to draw influence line diagram for reaction at C also. Can you please try? What is the influence line diagram? Vertical reaction. Just like the same we have discussed.
Sir, question repeat.
Draw the influence line diagram for vertical reaction at A. Any ideas as of now?
Sir, first of all, we have to consider AB portion.
Yes.
First step is we can remove that support reactions and introduce force.
Let us imagine that I have created artificial support like this. Right? Now, after that, apply unit displacement.
Apply unit displacement at A.
That means support at here ordinate is 1. Isn't it?
Yes, sir.
Now, what do you think? How it's gonna deflect?
Sir, 0
First
at
thing-
B.
As you know that, as it is a roller support, will there be any vertical deflection at B?
No, sir.
As it won't allow, right? As we are gonna
Won't
talk
allow.
about deflected shape. As it is a roller support, it won't allow any vertical deflection. Even if you look at support C, as it is a roller
Won't allow.
support again,
It won't allow,
again
sir.
it
It
won't
won't
allow
allow.
vertical deflection, isn't it? Now, as I'm telling you, as it is a determinate structure, you can blindly think that as we have already released one more force, it will form a mechanism. Mechanism means failure. Failure means whatever the lines you draw, that will be linear only. Now, let us say this is some point D. Deflection can happen at point D or not?
It will,
Deflection
sir.
can happen at point D.
Yes,
It will,
sir.
right?
It will, sir. It will.
At
At the hinge.
At point D,
At the hinge.
at point D, two members are connected.
Yes, sir.
Member DB and member DC.
Yes.
Will be slope same or different? Slope
In
of
this
DB and
case,
slope of DC.
in this case, same, sir, because the length is same, so slope is same.
Means you cannot judge like that. We will discuss that in detail now. But as of now, as I'm talking about hinge point, my question is the slopes can be different.
Obviously, sir.
Now,
At the hinge
what
point,
about at
slope.
joint? What at joint? It is just a continuous support, isn't it? It's just a support placed at continuous member. Then how many members are connected at B? BA and BD. As it is a continuous member, the slope of these two members will be same. Theta will be is equal to same. Now, at point C, what is the support? Roller support. Will it tell a rotation or not? Will it tell a rotation?
It will allow, sir. It will allow rotation.
That means inclined line can be formed. Either inclined line can be like this or inclined line can be like this, isn't it?
Yes, sir.
Now, imagine, obviously, if I am tilting this upward, imagine as a deflection at this point is B. Forget about this case as of now. Sorry. Let me redraw it again. Imagine it's like a seesaw. There is some balance at support B and you are pulling one thing in upward. How it may deflect? You can visualize, right?
Yes, sir.
Like this. Just like there is a support at B, and if you move onward, obviously the other person will goes down. Now let us see. Let us satisfy the criteria at B. Deflection is 0, and I am telling you that the slope should be same. In member BA, what is the slope direction? Here, see. Clockwise. Similarly, to the member BD, it is also clockwise. As it is rigid member, I will say that this is theta. This should be theta. Now, at this support, rotation is allowed, but deflection is 0. Then in this spot, how it may deflect? It may join like this. Now you can see here. What is the rotation in the member DB? For member DB, the rotation is in clockwise. For member DC, what is the rotation? In which direction it is? Clockwise or anti-clockwise?
So DC is anti-clockwise. DB is clockwise.
If there is a member D, if this is B and if this is C, with respect to reference position, this has rotated in a clockwise and this member is rotated in a anti-clockwise. So this is the slope theta dB and this is the slope theta DC. If the slopes directions are opposite, then how can you say that they are equal here? They are not, because they are rotating in the opposite direction. So that's why slope at this point is not same. First of all, is it okay about the deflected shape?
Okay, sir.
Yes, sir.
Everybody, all of you. Now let us represent the ordinates.
Clear.
What is the slope here? Here the ordinate is 1, total length is 10. So whatever the slope here?
1 by 10.
1 by 10. As it is a continuous member at B, what about the slope here?
1
This
by
slope
10.
and this slope will be 1. From here to here, what is the distance? 5 meter. And slope is 1 by 10. Then what about this ordinate? 5 into 1 by 10. How much? 5 isn't it? 5 into 1 by 10. How much it will be?
0.5.
0.5. Then similarly,
5, sir.
1.5. Then what about this? Again, I can say this is 1 by 10. Is it okay this idly? Is it clear? Any doubt in this diagram? Is it clear?
Sir, 1 by 10 at the C. I don't
1 by
understand.
10
At the
at
C.
C.
Yes, sir.
We know this slope, right? What is this slope?
Yes, sir.
1 by 10.
1 by 10.
What about this ordinate? This is 5 meter. Then what about this ordinate? 5 into 1 by 10. 5 by 10, isn't it?
Yes, sir.
From here to here again, what is the distance? 5 meter.
5.
Then what about this distance? Ordinate 5 by 10 by 5,
Load.
1 by 10.
So opposite by adjacent.
Yeah, opposite by distance. That's what we did. Here, luckily, 5 meter and 5 meter. That's why here the slope is same. Here the slope magnitude is same, not the direction. Again, don't tell me that at point D the slopes are same. They are different. But the magnitude here is same. Why? Because here also it is 5 meter. Here also it is 5 meter. Instead of 5 meter, if it is 7 meter, can you tell me what is the slope here?
So 5 by
Instead of
10.
5, if it is 7 meter, then what is the value? What is the ordinate? 5 by 10 by what is the length? 7.
By
How much it will be? 5 by 70.
5 by 70.
Clear, right?
Clear, sir.
No doubt.
No, sir, no doubt. Clear.
Similarly, now this is what
Clear,
I
sir.
ILD for VA. Now, let us say that if there is a load 100 kilonewton is moving from left to right. If the load is at B, if the load is at D for dog, if the load is here, what is the reaction at A? If the load is at D, what is the reaction at A?
0.5 into 10,
Tell me
which
the
is
max.
equal to 5 kilonewton.
Load is 100 kilonewton.
Load is 100 kilonewton means 50, sir. Then
If the
ordinate into load.
If the load 100 kilonewton moving from left to right, if it is at point D, what is the
D.
reaction at A?
So load into ordinate only, no, sir.
Yes,
So
that's right.
100
That's
into
what I'm expecting you. What is the answer?
50 kilonewton, sir.
What about others? Is it 50?
Yes, sir.
In this case, you have to see the direction. Is it coordinate 0.5? Is it in the negative direction or positive direction?
Towards left, negative direction, sir.
Doesn't matter. Doesn't matter about the direction of the load, whether it can move right side or whether it can move right, left side. What is the ordinate at point D? Minus 0.5 or plus 0.5? Minus
Minus,
0.5.
sir.
So minus 0.5 into 100 minus 2. If it is a positive means we can say that the reaction at A is in upward. If it is negative, the reaction is in downward. That means if your load is in between the span B to C, what is the direction of the reaction at point A? Once again, I'm telling, if the load is between B to C, what is the direction of the reaction at point A?
Positive, sir. Positive magnitude.
Direction of the reaction. The what is
Upward,
direction?
upward, sir.
Negative. See the ordinate place here in between B to C. What is the ordinates are placed in? Negative direction or positive direction?
Okay, I thought A to B. Okay, sir. B to C is negative ordinate.
So if the load is in between A to B, then the
Then it
reaction
is
at A will
positive.
be in upward direction. If the load is in between B to C, then the reaction at A is in downward direction. Yeah.
Clear, sir.
Similarly, quickly, can you guys find out what is the ILD for reaction VB? I will give you very much hint that at point B, what is the ordinate? 1. And I am giving the hint that at A it is 0 and at C it is 0. Remaining it very easy, you guys can work it on. Can anybody give me an idea?
Sir, tell me if I'm right. At the point A, we have a 0 ordinate. At the point B, we have 1 ordinate. At the point C, we have 0 ordinate. But the point D, the ordinate is more than 1, and I'm calculating. Is it right, sir?
Let's see. Let's talk about others. Here the first
They will-
question I'm seeing,
Triangle, sir.
obviously there is no portion in this doubt, isn't it?
Yes, sir, no doubt.
After that, either the members will deflect like this or the member will deflect like this. There are two possibilities, isn't it? Either member will deflect like this or the member will deflect like this. Let us say this is the first path and this is the second path, isn't it?
Yes, sir.
Which one we have to choose, path 1 or path 2?
One, sir, one, sir.
Part 2, sir.
Path 1 or
Path
path 2?
one, path one, sir.
Somebody said path 2. I just want to hear they are correct and how it is, how it, after that, how it gonna deflect.
Sir, it will deflect in downward, sir. At point D, there will be an ordinate, sir. Negative ordinate.
Like this
Yes,
and
sir.
then like this.
No, sir.
Yes, sir.
Now see, as I'm telling you, B is a continuous support. Is it right?
Yes, sir.
Not a continuous support, it is a continuous member at B, isn't it?
Yes, sir.
There is a beam like this and we have just placed a support below it. That means whatever the slope of the connected members at point B, it should be same or it should be different.
Same.
Let us say, I'm just drawing you in a separate diagram. And this is what the support be. Imagine that if it is deflected like this, let us say this is the B and this is the A and this is, let us say, just for the sake C. Can you tell me what is the direction of the slope in the member BA? Clockwise or anti-clockwise?
Anti-clockwise, sir.
Anti-clockwise. Similarly, what is the direction of the member BC?
Clockwise.
Clockwise. So if I'm drawing a structure like this deflected shape, that means are the slopes same or different? BA and BC. They both are not
Different.
equal, right? As it is a continuous support, the corresponding members should deflect same. So if I draw like this, then you can understand what is this slope? Anti-clockwise. Similarly, what is this slope again? What is this slope? Anti-clockwise. So always remember, wherever you are breaking it into two opposite sides, that means here see, you have break it into two parts. You are applying rotations in two different directions. Imagine, take your hand and try to rotate along the direction. One you will rotate in anti-clockwise, one will rotate in clockwise. So wherever you are considering different rotation, indirectly you are treating them as a hinge connection. As in the present case, B is a continuous member. As it is a continuous member, slopes should be same. As slope should be same, do we have to go for path 1 or do we have to go for path 2?
Path 1, sir.
And if you consider path 1 only, your slope will be same. And then it will deflect like this. And after that, at D, what is the support there? Hinge support. As it is a hinge support, rotations can be different. So the orientation will change and then it will meet to C. You can see at this point, both are rotated in different direction. That means it is a hinge connection. Clear? Any doubt in this diagram? So here the logic is that if you can understand that at joint B as the rotations are same, then you will take up the inclined line only. That's it. Can you tell me what about this slope?
1 by 10.
Ordinate is 1, distance is 10, 1 by 10. As it is the same straight line, the slope is same. What about this ordinate? From A to D, what is the total length? 10 plus 5, 15. What is the slope? 1 by 10. So 15 into 1 by 10. So 15 by 10, that will be equal to 1.5. Then what about this slope? What is this length? 5 meter. What is the ordinate? 1.5. 1.5 by 5. How much it will be? 0.3. Any doubt in this diagram? ILD for reaction at B.
No, sir.
Clear? Now, is there any possibility that negative or downward reaction possible at joint B? You can see the ordinates. Every ordinate is in the positive direction. That means reaction at B is always in the upward direction. Now tell me, where or what is the position of the load such that maximum reaction at B will develop?
At the D.
Sir.
If you look at this diagram, where is the maximum ordinate? Maximum ordinate is there at D. So if you place a unit load at point D, then at this point, the maximum reaction will develop at support B. Clear? Similarly, can you guys try it for ILD for VC? Draw it for ILD for VC. Again, try it in a similar way and let me know how you guys are getting the reflected shape.
Sir, from A to B, it will be 0 only, sir.
See,
A to B, it will be C for a reaction at. It will be 0, 0.
0 from where to where?
A to B.
D to B.
A
That's
to
it.
B.
Can I erase VA and then can I replace with C? Or can I draw it somewhere else? Anybody have completed? If I move it to the upward direction, 1, I know here the deflection is 0. Here also the deflection is 0. And how they are going to deflect? Linear lines or linear lines, right? So the best example for this is imagine your complete hand, shoulder, joint, and then at your fingers. At your fingers, imagine it is a support C. In between joint, imagine this is a joint D. And then shoulder, imagine it as a support B. Try to lift your fingers upward direction. How you are going to see the deflected shape? If you lift your fingers in upward direction, imagine this is shoulder, this is in between joint, this is fingers free hand side, and try to lift it in upward direction. Tell me how it's going to deflect it. Can I simply say this? As you can see, deflection 0, deflection is 0, BC slope is 0, and then DC the slope is existing. What is that slope? 5 meter, 1 by 5. Now tell me, this is what ILD for VC. So, if the load is in between A to C, or if the load is in between A to D, what about the vertical reaction at C?
0.
If the load is in between AC, what is the vertical? 0. That means the reaction at C will develop only when if the load is in between the portion D to C. Otherwise, remaining portion is 0. So in this case, the load will exist or the reaction will exist at point C if there is a load that is in between D to C. Clear? Any doubt? Pin drop silent. Why? In this case, any ambiguity?
No, sir, clear, sir.
If it is clear, what is the ILD for reaction at A? What is ILD for reaction at A? Quickly.
Sir, it looks like not a triangle, sir. Is it
Sorry?
rectangular shape?
Which one?
ILD for VA, because at the B,
This
we
is the
don't
case
have
you're
any.
talking. This is the case you're talking about, right? Take
Yes,
some
sir.
time and think about yourself and get back to me in 1 minute. Don't just think yourself and let me know which one is correct, which one is right. At A, initially, is there any displacements possible? What is the vertical deflection, horizontal deflection, and rotation? Everything is zero, isn't it? Now, what we want
Yes,
to draw?
sir.
We want to draw vertical reaction at A. That means what we should do? We have to release only one force. That means we have to apply only vertical displacement. Still, horizontal deflection, delta H is 0. Rotation is also is equal to 0. What if rotation is equal to 0? The member will be horizontal or inclined if rotation is 0.
Horizontal.
Horizontal, right? So I have to move this by displacement 1. And then I can see the rotation will be 0. If the rotation is 0, member will be horizontal. At joint B, it is a free thing. It can allow vertical deflection, horizontal deflection, and rotation. But what you can see, as the slope is equal to 0, here the member will be horizontal. In this case, how it's going to look like this. If you draw in case, it won't be possible. Why? Because that means in this case, you're representing the slope. As it is a fixed support, it won't allow any rotation. That's why this is the wrong. In this case, only if you draw like this only, in this case, the rotation is equal to 0. That means wherever the load is, whatever the reaction there, let us say if the load is P, wherever it is, whatever the vertical reaction, obviously P, isn't it? So that's why it is a rectangle. Is it okay? If it's okay, then we can move on to the shear forces and bending moment. Similarly, let us say ILD for shear force. Let us say joint A, joint B, and let us say there is some point C. It is at a distance of L by 2 and L by 2. And imagine there is a point load P is moving over the beam. Then we have to draw what is the ILD for shear force at C. Just like in the same case, imagine if there is a load somewhere here, if it is at a distance of X. Can you tell me what about the reactions? What is the reaction developed here and what is the reaction developed here? We have already seen. What is the reaction here? Into opposite distance X by L. What is the reaction here? P into what is the opposite reaction? L minus X by L. Right? Now, imagine in first case, imagine that load is at left of C. That means in first case, imagine that the load is in between A to C. Can you tell me what is the shear force at C? First of all, tell me how you will find the shear force. I just want to hear it from your words. Can you tell me, or somebody please tell me how we'll find the shear force at a point?
So the total force present either to the left of that particular point or to the right.
Either to the right or to the left. Wherever you are finding the bending moment or shear force, one thing we should remember, what is it? Always look at only one side. We have to look it from only one side, that's it, right? Imagine, in the first case, where is the load? The load is at somewhere here. Where we have to find the shear force? We have to find the shear force at C. Let us say we have to find the shear force at this section. If you look into the right side, how many forces are there?
One, sir.
One. If you look into the left,
Two forces.
so if it is a shear force, you can say algebraic sum of forces either to the left or right of a section. So in this case, which one will you prefer? Will you look into the right side or will you look into the left side? You guys are very smart people. Into the right side,
Side.
how many forces are there? One. If you look into the left
One.
side, how many forces are there? Two. Will you add two forces and then find out the value, or you'll directly take the single value? I think you guys will directly go take the single value. So I will look into the right side and I will tell you what is the shear force. P x by L. What is the sign convention that we have to use?
Positive, sir. Upward positive.
What is the sign convention for shear force
Upward
diagram?
positive. Left side upward positive.
You have to run. It is simply to remember, right? Run. R represents right side, U represents upward, N represents negative. If you are looking on the right side, if the force is in upward, you have to take it in a negative direction. So I'm looking onto the right side and my force is in which direction? Upward. So I have to take it as a negative. Similarly, again, if the load is at right of C, that means if the load is in between B to C, what is the shear force at C? Now this is the case I'm talking about. If the load is in between B to C, consider a section here. If you look into the right side, how many forces are there?
Sir.
Look into the left side, one. So what is the easiest way to left side? So you're looking into the left side and there is a force in upward. Right side upward is negative. Left side upward is positive. So what is the shear force? P into L minus X by L. Is it right? In portion AC, we are having shear force in positive direction or negative direction. If the load is in between A to C, what is the shear force direction? Negative. The load in B to C, what is the shear force direction? Right? Now, just a second. Let me increase the size of the screen. Consider the same thing. A, B, and imagine if you are finding the shear force at point C. Let us say it is at a distance of L by 2 and L by 2. What is the logic that we have discussed here? According to the deflected shape, what we have to do? We have to release that force and apply the unit displacement. As I told you in the previous case, just a second, let me go to the previous diagrams and then, yeah. In this case, as I told you, can we define the shear force at point B? Am I audible, guys? Yeah. Can we define the shear force at point B in this case? We cannot, right? So that means wherever the load is acting at that point, as we cannot define the shear force, what we should do? At that point, we have to imagine just to the right, and at that point, we have to imagine just to the left. In the same case, here, first of all, we have to release the force. To release the force, which type of support can I place here?
Roller support.
I cannot directly say roller. I can say that axial shear connection. So if I place a shear connection, and then, as I told you in this case, to the right side, we will have the positive shear. To the left side, we are having the negative shear. Move the right side part in the upward direction and try to move the left side part in the downward direction. Why I have to move in different directions means, as at this joint we cannot directly define it. Move the right side part in the upward direction and move the left side part in the downward direction. If you try to move it in the upward direction, then at this point the slope is 0. So the deflected shape might be like this. Similarly, as it is moved to the downward direction, the deflected shape might be like this. What I have told you? Oh, sorry. But as we are releasing only this shear, the slope will be the same direction. Whatever the slope here, you can see what is the direction? Clockwise. Now similarly, you can see what is the direction here? Clockwise. Understand? So here the slope will be same, that in the clockwise direction. Here also the slope will be in the clockwise direction. That means we are not in terms. Yes, please.
Sir, the sign convention, still I have a doubt.
Yeah, please.
The portion A to C, we have a positive shear, right, sir?
The portion?
A to C. In between A to
Yeah.
C, do we have a positive shear?
Positive shear or negative shear?
Positive shear only, sir.
How?
How can we say the negative shear?
We are talking about at point C. At point C, can you tell me what is the sign convention that you follow?
Left up is positive.
Left up is positive, then right up is negative. Is it right?
Right.
Right
Left
upward
up
negative.
and right down. Left up and right down as positive. So now we are considering the portion
Right.
A to C.
Right down is positive, then right upward is negative. I have remembered like this during my preparation run, right side upward negative.
Are you
Even
considering the load or reaction, sir?
forget about anything, whatever the force you consider, it doesn't matter whether you consider applied force, whether you consider reaction force, doesn't matter. If any force, if it is right side and if it is an upward direction, you have to treat them as negative sign. Imagine if I'm talking about a section, if there is a force like this, if I'm looking at the right side, the force is an upward, this will be the negative. If the force is in downward, this will be positive.
Yes,
Similarly, present on the left side, this will be positive,
positive.
this will be negative, isn't it?
Yes, sir.
Now, in this section, if you look into the right side, how many forces are there?
Right side is only
One, sir.
Only
one
one.
force.
So according to our
too-
sign convention, right side, it is an upward.
Upward is negative.
Yeah, that's what I have written here.
But in the diagram, it look
Yeah.
like the opposite manner. Like
Here.
the above line, above AB line, generally we will consider as a positive. Below AB line, we will consider it as a negative. So it should be the negative value, right?
Imagine if it is ACB. Can you tell me again which portion you will consider upward and which portion you will consider it as a negative?
CB is negative.
CB is negative.
Yes, sir.
Why again?
Sir, slide number 109, the right side portion, the upward direction is taken as negative.
Yeah.
Like in the same way, in the beam, we have the portion
Just a
between
second.
C.
Just a second. If the load is in between A to C,
That is why I'm asking, sir. So are we considering the load or reaction? So are we considering the load, right?
see, yes, I'm telling you two different cases. This is nothing but a moving load, right?
Yes, sir. If we consider the load, then it is negative, sir. Then positive, then positive. If we consider the load, then the diagram is okay. Positive only.
Listen, the point is shear force at C, isn't it?
Yes, sir.
Our target is we have to find the shear force at C,
Yes, sir.
right? Positive or negative, this value we are deciding based on the position of the load.
Okay.
The position of the load is in between A to C. First condition where if the loading position is A to C, it doesn't matter wherever it is.
Okay.
What about the shear force at this section? If you want to find the shear force at this section, either you can look into the right side or you can look into the left side, isn't it?
Yes, sir. Okay.
Whatever may be the position of the load, right? If you look
Okay,
into the
sir.
right side, how many forces are existing here? Only one.
One force.
Whatever the position of the load in between A to C, can I simply say what is
A
my
to
shear
C.
force at C? Px
Is
by L.
left down is negative.
Okay, left down is negative. Right up is negative.
Okay.
Either you want to take it from left side, I can.
No, sir. Now I'm clear. If we take the load, then
Load.
the sign is okay, sir. So we are taking the load, right? Okay, sir.
Here the point is, just for the simplified purpose, I am telling you that to take it from right. Even if you don't want to take it from right, you can take it from left too. You will get the same answer. If your load is in between A to C, if you take the shear force at point C, that you will get it as a negative only.
Okay.
Let's do one thing.
Yeah.
Yeah, what we can do is that whatever we have discussed, just go through this. And I don't know whether Vinod sir informed you or not. I told Vinod sir I'll take tomorrow class 2. Did sir inform you? Are you guys free tomorrow?
No, sir. Sir, not
Sir
any.
didn't inform, sir. I
Okay,
think
you
he
guys
will
are free, right,
free
tomorrow?
Yes,
Yes,
sir.
sir.
Please.
Okay, then I think tomorrow class will happen. So just
Okay,
go
sir.
through the basics, whatever we have discussed. and then we'll continue tomorrow briefly.
Okay.
I
Okay,
don't
sir.
want to rush up in this time.
Okay.
Okay,
Okay, sir.
Okay. Thank you,
Okay,
guys.
sir.
And
Thank
just
you,
please
thank
go
you,
through
sir.
them. And because it's not easy to understand, just go through them and we'll discuss in clearly.
Sure, sir. Thank you, sir.
Okay. Thank you, guys. Thank you.
thank you, sir.
Just go through the sign conventions too.
Okay,
Okay.
sir.
Sure,
Sure.
Okay
sir.
then. Thank you.